Let's look at another word problem. This is problem 64 from the review of chapter 6. The current of a river moves at 3 miles per hour. All right, let's draw a little picture. So here's our river. Here's the current. It's moving at 3 miles per hour. It takes a boat a total of 3 hours to travel 12 miles upstream against the current and return the same distance traveling downstream with the current. So a boat takes a trip. It goes upstream against the current, turns around, goes downstream back to the starting point. It traveled 12 miles going upstream, turned around, traveled 12 miles going downstream. And that total time that it took, notice that's the key, it was the total time. The total time that it took for the upstream and downstream trip was 3 hours. What is the boat's rate in still water? All right, so let's let R be the boat's rate in still water, meaning there's no current. How fast, what's the top speed of the boat if there was no current? That's the idea of the boat's rate in still water. Now, that whole idea of the total time, totals come about by adding things together typically. I mean, that's typically we think about a total. What's a total? Typically you were adding things up. In this case, what were we adding to get those 3 hours? Weren't we adding the time that it took for the boat to go upstream plus the time that it took for the boat to go downstream? Aren't those 2 times equal to the 3 hours total that the boat traveled going up and back down? See, I'm always looking, when I solve a word problem, I'm always looking for things that are equal, because that's what I need to create. I need to create an equation. So equation says things are equal. In this case, what's it saying? It says that total of 3 hours, well, totals come from adding things together. The sum of those 2 times is what equaled the 3 hours. Now I just have to somehow express time in some algebraic terms to create my algebra equation. Well, remember, distance equals rate times time, so time can be expressed as distance divided by rate. What's the distance that we traveled upstream? 12 miles. What was our rate as we traveled upstream? Well, when you're traveling in a boat against a current, isn't your rate the top speed that the boat can do minus what the current is resisting it? The top speed the boat can do is what we're trying to find. We're representing that with R. And the current that was fighting us was 3 miles per hour. You know, if the boat's top speed is 17 miles per hour, you lost 3 miles per hour because of the current pushing you downstream. So your effective rate was only 14, 17 minus 3. Whatever your top speed is minus the speed of the current. When we turn back around, expressing time as distance divided by rate, well, the distance was again 12 miles, wasn't it? Because we returned to our starting point. But this time, the current sped us up. Because no matter how fast the boat is going, the water itself is moving along, and we're in the water, it's moving along at 3 miles per hour. So our top rate plus the 3 miles per hour is our rate going downstream. Distance divided by rate is time. Plus distance divided by rate is time. Time plus time, the total time was 3 hours. We have our equation we can solve. We're going to solve this rational equation by picking the right multiplier that will cancel out the denominators. Well, this fraction would require a multiplier of r minus 3. So I have to multiply everything times r minus 3. This multiplier would require a multiplier of, that denominator would require a multiplier of r plus 3. But I have to multiply everything by the same quantity. So the multiplier I want to use times both sides of the equation is the pair of binomials r minus 3 times r plus 3. Let's shift up a little higher here. Get rid of my lovely drawing. Switch pens at the same time since they're all kind of getting weak. When we multiply here, won't those r minus 3's cancel, leaving us 12 to be multiplied times the binomial r plus 3? Here, the r plus 3's will cancel, leaving us plus 12 to be multiplied times the binomial r minus 3. And here, we have 3 to be multiplied times that pair. R minus 3 times r plus 3. Not that the order is significant. We're multiplying. Multiplication is commutative. We could have written it either way. Now, let's go ahead and multiply through so we can see what kind of equation we've created. That's going to give us 12r plus 36 plus 12r minus 36. Hopefully we would recognize, what's r minus 3 times r plus 3? Isn't that the special binomial case that's going to be r squared minus 3 squared, which is r squared minus 9? And then we're going to take that r squared minus 9 that we create when we multiply those two and multiply through by 3, which will give us 3r squared minus 27. And we have a quadratic equation, which we will first put into standard form. Well, plus 30x minus 30x, those disappear into 0 when we combine the like terms there. This side we have what? 24r, so we'll have to subtract that from both sides. So our equation will become 3r squared minus 24r minus 27 equals 0. We should notice that each of those terms contains a common factor of 3. So let's factor that out to hopefully make our remaining factoring simpler, if indeed this trinomial is going to be factorable. Wouldn't we have r squared minus 8r minus 9 if we factored 3 out of each of those terms? Now let's see if that trinomial can be factored into a pair of binomials. Because that's minus 9, one will have to be plus, one will have to be minus. And wouldn't r plus 1 and r minus 9 give us minus 8r under the O and the I of FOIL? The O of FOIL will be minus 9r, the I of FOIL plus 1r. Those two combine to minus 8r. And our two solutions here are r equals negative 1, r equals 9. Both of which are perfectly legitimate solutions to that quadratic equation, but one of which doesn't make any sense in the problem. Remember what r was representing. I've had to erase it now because of space limitations, but what r was representing was the speed of the boat. Well, we wouldn't think of the boat's speed as being negative, so we can simply dismiss this solution in this application problem. So we have r being 9, the top speed of the boat was 9 miles per hour. And we say something like that. Speed of boat was 9 miles per hour. Remember, put some words with your number to make your answer meaningful in a word problem.